Okay, so we have the combined level 1 and 2 for this standard. If you are able to do only 3 of the things that I'm asking within this standard, then you are at a level 1. But if you're able to do all of the things that I'm asking, there are 5 of them, then you would be at a level 2. And so we're going to get started. We're going to be graphing quadratic functions in this unit, so we do need to know that the graphs of a quadratic function, quadratic functions are nonlinear functions that create a symmetric curve with the highest or lowest point called the vertex. The graph is called a parabola. All right. On a parabola, there is a line of symmetry, which is called the axis of symmetry, sometimes abbreviated as AOS. The axis of symmetry will run through your vertex of your graph always. The vertex is where the graph is going to split into the symmetric curve. To find the axis of symmetry, we would take the opposite of our b value in our equation divided by 2a. This is actually the x value of the vertex. So the x value of the vertex is the same that you would get for the axis of symmetry. All right, so now we're going to talk about roots, zeros, and x-intercepts. These are actually the solutions to your quadratic function. So if I ask you for the roots, the zeros, or the solutions to a quadratic function, what we are really looking for are the x-intercepts on the graph. Now, in numbers 1 through 5, I am asking you for the zeros, roots, and oops, that should say x-intercepts. That's a typo there. What I'm really looking for are the solutions to these quadratic equations. And now we have already done this in the last standard. So this is just a review of what we did in the last standard. Now, when you're finding the x-intercept on the graph, that means that your y value is 0. So what we do need to do for each of these equations is put 0 in for y, and then we will be able to solve each quadratic equation. So I'm going to do that for each of these. And again, the reason why I'm doing this is because when I'm asking you for the x-intercepts on a graph, that means y is a value of 0. So I'm putting 0 in for y. Now we are going to review each of the methods that we learned in the last unit. So square roots, factoring, quadratic formula, and completing the square. We are going to review all of those. Okay, in number 1, since your b value is 0, we're going to use the square root method by first adding 16 to both sides. I have a 9x squared is equal to a 16. I'm now going to divide by 9 on both sides, and I wind up with an x squared is equal to a 16/9. And then I'm going to take the square root of both sides, and I get x is equal to a positive or a negative 4/3. What this means is that if I were to graph this equation on my graph, then my graph, my parabola, would intersect the x-axis at positive 4/3 and negative 4/3. Now in number 2, this is already in factored form, so we can use the zero products property to solve for x. I'm going to take my 2x minus 5 and set it equal to 0. And then I'm also going to take my x minus 8 and set it equal to 0. Now I'm going to solve both of these equations for x. In my first equation, I would need to add 5 to both sides to be left with a 2x is equal to a 5. And then if I divide by 2 on both sides, I get x is equal to a 5/2. In my second equation, I'm going to add 8 to both sides, and I just get x is equal to 8. So my answers, my solutions, my roots, my zeros for this, that means the same, those all mean the same thing. My solutions are x is equal to 5/2 and x is equal to 8. What this means is that if I were to have graphed this quadratic equation, my parabola would cross the x-axis at 5/2 and 8. All right, looking at my next one, I'm going to use factoring. I'm going to review that with you. And for this one, we're going to need to use the x method. So I draw myself an x. My a times my c would be a 30x squared. And then my b value is a negative 11x. So I would need two numbers when multiplied together equal a 30x squared, but when added together equal a negative 11x. That's going to be a negative 5x and a negative 6x. So now I'm going to rewrite my equation, but instead of writing that negative 11x, I'm going to write a negative 5x minus a 6x. Now I'm going to use the grouping method. My GCF out of my first two terms is just an x, and I'm left with a 2x minus a 5. I would need to take out a minus 3 out of my next two terms to be left with a 2x minus 5. So one of my binomials is an x minus a 3, and my other binomial is a 2x minus 5. So now using the zero products property, I'm going to set one of my binomials equal to 0 and my other binomial equal to 0. And now I'm going to solve for x in both of these equations. So in my first equation, I'm going to add 3 to both sides, so I get x as a value of 3. In my second equation, I'm going to add 5 to both sides, so I have a 2x is equal to a 5, and then I divide by 2 on both sides to get x is equal to a 5/2. So one of my answers was a 3, my other answer was a 5/2. This would be, if I were to graph this parabola on the graph, I would get this parabola crossing my x-axis at 3 and 5/2. Looking at number 4, I'm going to show you the quadratic formula for this one. So I have it already set equal to 0, so I have x is equal to the opposite of my b value, which would be 3, plus or minus the square root of my b squared, a negative 3 squared is a 9, minus a 4 times my a value of 5 times my c value of negative 22, all over 2 times my a value, which is 5. Now I'm going to simplify some things. I'm going to simplify what's underneath my square root and also what's in my denominator. So I really have x is equal to 3 plus or minus the square root of. And then in my calculator, I'm going to type in 9 minus 4 times 5 times negative 22. And I get a 449. And then all over a 2 times a 5, which is a 10. Now I'm going to type this into my calculator carefully. I'm going to put parentheses, 3 plus the square root of. Your calculator puts these parentheses in there, so I do need to close my parentheses twice after I type in the 449, close my parentheses twice, and then I do divide it by 10. And it does say to round to the nearest hundredth if we need to round, and in this case we do. I get a 2.42. Now I'm going to do the same thing, only I'm going to do a minus sign instead. Parentheses 3 minus the square root of 449, close your parentheses twice, divided by 10, I get a negative 1.82. And those are your two x-intercepts. All right, and number 5, lastly, we're going to review completing the square. And so what we're going to do first is get my coefficient of x squared to be 1. And how I do that is I need to divide everything by 4. So a 0 divided by a 4 is a 0. A 4x squared divided by a 4 would be an x squared. A negative 4x divided by a 4 would leave you with a negative x. And a negative 24 divided by a 4 leaves you with a minus 6. Now I'm going to move my constant to the other side by adding 6 to both sides. So I get a 6 is equal to an x squared minus an x. Now I take my b value, which is 1, I divide by 2, and I square that number. A 1/2 squared is a 1/4. I'm going to add 1/4 to both sides. So on my left side, I'm going to do a 6 plus a 1/4, but I'm going to rewrite 6 as a 24 over 4, because 24 divided by 4 is a 6. So I wind up with a 25/4. And this will equal, I take the square root of my first term, which would be x, square root of my last term, which would be a 1/2, and the operation in between my first and second term, which is a minus, and I square that number. Now I'm going to take the square root of both sides, and I wind up with a positive or a negative 5/2 is equal to an x minus a 1/2. Now I'm going to add 1/2 to both sides, and a positive 5/2 plus a 1/2 is a 6/2, and a 6/2 is really a 3. And a negative 5/2 plus a 1/2 is a negative 4/2, and a negative 4/2 is really a negative 2. So I wind up with the x values of 3 and negative 2, which those are my solutions, my roots, or my zeros, meaning that if I graphed this quadratic equation, the parabola would intersect the x-axis at the points 3 and negative 2. All right, so we will need to be doing finding the roots and the zeros and the x-intercepts within this standard again. This is a very important concept that you will carry on throughout high school. So we're reviewing this again because you will see this a lot in the upcoming years. But this is the end of levels 1-2, lesson number 1. And then you will have lessons 2 and 3 for the levels 1-2. So go ahead and move on to the next lesson.